Question 3. This question is about chromium and its compounds. Complete the full electric configuration of chromium atom. Chromium, 24 electrons, but obviously it's got that special case, so you should learn full electric configuration of chromium beforehand, or just the end part. Chromium is 24 electrons. 24. 1s2, 2s2, 2p6. 3s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, what we on now? So 2 plus 2 plus 6 plus 2 plus 6 plus 2, 20. We still need 4 more. 4s2. So what do we add now? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Right? But obviously this has got a special rule. And what's going to happen is this electron is going to go here. So it's going to be 3d5, 4s1. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. Let's do 2p6, 2s2, 3p6, 3d5, 4s1. Then 3.2, atom has 2 more protons and 3 more neutrons. Then atom of 52Cr. Introduce a sample including introduce a symbol including the mass number and the atomic number for this atom. 2 more protons and 3 more neutrons. Then atom of 52Cr. So let's have a look at this 52Cr24. How many how many neutrons does it have? Well, it's got 52 minus 24 give me 28 neutrons. How many protons? 24 protons. 28 and 24p. This atom that we want to introduce a symbol of has 2 more protons and 3 more neutrons, so it's going to be 31 neutrons, 26 protons. So the easiest way is look at the bottom number and it should be 26. And there we go. Look at iron. 26, so it's going to have to be Fe 26. But obviously it can't be 55.8 for the top. The top must be 26 plus 28, which is 50. No, 26 plus 31, because we want 3 more neutrons, so 31, 57. So 57 Fe 26, or 57, 26 Fe. Bit tricky, but should get your head around it. First calculate the number of protons and neutrons in chromium, 52Cr, and then realize 2 more protons, so it's got to have 26 protons, 3 more neutrons, got to have 31 neutrons. Where's 26 protons? That's iron, Fe. So what must the top number be to give you 31 neutrons? Well, it must be 26 plus 31, which is 57. And remember, Fe, the iron. 3.3, sample of chromium contains 4 isotopes of relative atomic mass of this. Determine the percentage abundance of the 4th isotope. Well, let's finish the table off. Let's do something like this. The mass number is what we're trying to find. We're trying to show it's 50. But the percentage abundance, well, we know the total percentage must add up to 100, so it's just going to be 100 minus 82.8 plus 10.9 plus 2.7. 100 minus 80.8 plus 10.9 plus 2.7, 3.9. percent. So we know this is 3.9. Now what we don't know is the mass number. We're trying to show the mass number is 50. So we're going to treat it as y for now. Now let's substitute the values in. So we know that AR is 52.09. Also the total mass is going to be 52.09 is equal to 52 times by 82.8 plus 53 times by 10.9 plus 54 times by 2.7 plus 3.9y divided by 100. Percentage, right? Then move this to the left hand side, so we get 52.09 equals, and now let's put this in the calculator. 52 times by 82.8 plus 53 times by 10.9 plus 54 times by 2.7, 5029.1 plus 3.9y, or x, doesn't really matter. 3.9y equals 5209 minus 5029.1, 179.9. Therefore y is going to be 179.9 divided by 3.9. Oh, it's not 3.9. 100 minus 82.8 plus 10.9 plus 2.7. 3.6. Sorry for that. 3.6%. Simple calculation. I could have got the whole question wrong, or at least half of it. So it's 3.6%, so it's going to be 3.6y. But then everything else is correct. So then 179.9 divided by 3.6 will give me 49.97, and therefore that is very close to 50. Therefore y is equal to 50. So there we go. Just don't do what I did and incorrectly put in your calculator 100 minus 82.8 plus 10.9 plus 2.7. It's 3.6%. Then you substitute the values in and treat this as y, algebra, rearrange it, you get y, and then yeah, you can say therefore the calculation has shown that the mass number of isotope is 50. 3.4, to reduce the oxidation state of chromium in the Cr2O72 minus ion. So we know the overall charge is 2 minus. Oxygen is going to be minus 2 times by 7 minus 14. Minus 14 plus 2 Cr equals minus 2. That's what we're basically saying, because the total overall charge is minus 2. So what must Cr be? Well, this must be 12, because 12 plus minus 14 is minus 2. But that's for 2 Cr. So the oxidation state of chromium in this is just going to be plus 6. And then 3.5 iodide ions can be oxidized to iodine using Cr2O72 minus ion. Use a half grain to show the oxidation of iodide ions to iodine. Iodide ions to iodine. So I minus to iodine I2. Well, we've got 2 here, so we need to have a 2 here. But now we've got a negative charge of 2 here, so we need to have 2 negatively charged electrons to balance the overall charge. Then the juice half equation show the conversion in acidic solution of Cr2 O72 minus to Cr3 plus. Cr3 plus. It's still going to be a bit tricky compared to 3.5. Okay, so we've got 2 Crs here, we've only got 1, so we need a 2 here. but we've also got 7 oxygens here, so we need to add. We can't add oxygen directly, we need to use water molecules, or H pluses, remember. In this case we're going to use water molecules, so it's going to be 7 H12. That'll give me 7 oxygens here. But now we've got 14 H pluses here, so we need to add 14 H pluses here. So are we the same number of atoms on each side? We've got 14 H pluses on the left hand side, 14 H pluses on the right hand side, 7 oxygens, 7 oxygens, 2 chromiums, 2 chromiums. But now the charges need to balance. We've got an overall charge here of 12 plus 12, because 14 plus 14 minus 2 plus 12, and an overall charge here of 6 plus. So what we need to do now is just add 6 negatively charged electrons here and get the overall charge of 6 on both sides. So yeah, 6 plus on the left hand side and 6 plus on the right hand side. And then it says reduce the overall redox equation. What we need to do is we need the negative electrons to be the same, so we need to times this by 3, so we get 6i minus arrow. This is not part of 3.5, but I just need to warn you. 3i2 plus 6e minus. 3 times 2 is 6. 3 times 1 is 3i2 plus 6e minus. Now we add them together, so we're going to get 6i minus, these two equations together, 6i minus plus 14h plus plus Cr2O72 minus arrow 3i2 plus 2Cr3 plus 7H2O, and the negative 6 negative electrons here cancel out, so left with 6i minus plus 14H plus Cr2O72 minus arrow 2Cr3 plus 7H2O plus 3i2, and that is the end of question 3.